All right, welcome to the last lesson for this week. This is 11.3. We're dealing with compound probability, which means we're looking at the probability of multiple events. So let's start by looking at what's the probability of flipping a heads on a coin, then rolling an even on a die. Well, let's go through this the long way, the way that we know. I said long way because we'll be dealing with a shorter way. So you have the potential to flip a head or a tail, and then after that, you can roll a 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, or a 6. You can do the same for tails. 5, 6. As you can tell by the frantic writing and moving of this becomes a pain. But let's look at our total sample space. Well, we have heads in 1, heads in 2, 4, and we have the same for tails. So how many of these have us flipping a heads and then rolling an even? Well, we have that one, we have that one, we have that one. So that's 3 of these out of how many? 1, 2, 3, 4, 5, 6, 12. Or we have a quarter chance of doing that. Now, some of the time you have to look at the entire sample space to do this, but that's not always true. A lot of times there's a quicker way for us to do that. It depends, however, on the type of events we're looking at. So we have 2 different types of events. We have independent and we have dependent events. Independent and we have dependent events. And what independent events mean is that the outcome of the first one or outcome of one doesn't affect the outcome of the other. So this would be something like flipping a coin, then rolling a die. We don't expect one of those to have an effect on the other. Whereas dependent would be outcome of one affects the other. So this would be something like pulling 2 cards out of a deck. Once you pull the first card and you don't replace it, right, it goes into your hand, now you've changed the likelihood of pulling any other card because there's one less card to pull from. All right, so this is an example of flipping a coin, then rolling a die. And this is going to be drawing 2 cards. And so what happens is if you have independent events, the probability of one thing happening, A happening, then B happening, is just the probability of A times the probability of B. So it's the probability of your first event times the probability of your second event. And that is going to be for dependent events, the probability of A then B is going to be the probability of A, so drawing that first card, times the probability of getting B after whatever A was. We'll be dealing with this a little later, so you won't have to worry quite as much about this one. Actually, we'll be dealing with it now. I don't know what I'm saying. And then finally, we're dealing with one more. What's the probability of A or B? Well, that's the probability, like we talked about in the last lesson, of one plus the probability of the other, but then we have to subtract our overlap. Okay, we'll be dealing with that a little bit later in the lesson. Now let's get started with some practice. Let's say you have some marbles in a bag. You have 3 red marbles, you have 2 blue, 2 yellow, and 1 green. So what would the probability be of pulling a red, then a blue, when we have replacement, meaning we're going to take one and then put it back in. So replacement means we don't affect anything, right? We have the same number of total marbles in the bag, so nothing gets affected. These are independent events, meaning that this is going to be the probability of pulling a red in the first time. That's going to be 3 out of 8. So we'll have a 3/8 chance of pulling a red. Then we'll have a 2/8 chance of pulling a blue, meaning that our probability of pulling a red then a blue with replacement is going to be 3/8 times 1/4, or 3 out of 32. Right, what about if we pulled a red then a blue, but this time we weren't replacing, so we stole that red marble, we pocketed it. Now these are dependent, because pulling that first one changes the outcomes of the other one. So what's the probability of pulling red? Well, it's again 3/8. But then what's the probability of pulling blue after that? Well, we have one less red here. So there's 2 reds, 2 blues, 2 yellows, and 2 greens. So it's 2 out of 7 now, because we have one less marble. And this becomes 6 out of 56, or 3 out of, what would that be? 28. Okay, what about the probability of pulling a green then a green with replacement? So the probability of pulling a green then a green, well, the first time we have a 1 in 8 chance of getting it. Then the second time we have a 1 in 8 chance of getting it. Right? We put it back, we pulled it again, so we're going to have a 1 in 64 chance of pulling that. All right, what about if we pulled a green then a green without replacement? And this is without replacement. So first chance we have is 1/8 of pulling a green, but the second time we have no greens. So what's the probability? We have 0 greens that we can pull out of 7, meaning that we have a 0% chance, or it's impossible to pull a green and then a green. All right, now let's deal with ors. So this is dealing with the probability of pulling something like a blue or a red. We said that the probability of A or B is going to be the probability of A plus the probability of B, and then we have to subtract the overlap. Now we have a special kind of name for some of these where there's not overlap. We call those mutually exclusive. And you might have heard this term before. It comes up a lot when we're discussing generally in normal day-to-day discussions. It's an important word to have. So mutually exclusive means there's no overlap, or these two things cannot happen at the same time. Or there's no overlap. Right, so let's look at some examples. Let's say you're rolling a die. What's the probability of rolling a 3 or a 4? Well, so is there any overlap? If you roll a 3, can you roll a 4? No. So these are mutually exclusive. Right? They cannot happen at the same time. These are mutually exclusive. What's the probability going to be? It's going to be the probability of rolling a 3, which we know is 1/6, plus the potential of us rolling a 4, which is going to be 1/6. Or, right, we can combine these together, so it's 1 plus 1/6. But we don't have to subtract anything. There's no overlap. So the probability is 2/6, or 1/3. What about the probability of rolling a 3 or an even? Well, the probability of rolling a 3 is 1, right? There's 1 opportunity. Evens, there's 3 opportunities. We have 6 outcomes. Is there any overlap, though? Well, we have 3s and we have evens. 3 is an even. There's no overlap, meaning this is also mutually exclusive. And our probability is 4/6, or 2/3. All right. What about if we're looking at the probability of rolling a even or a multiple of 3? So this probability is going to be, there's 3 different evens we can pull, and then multiples of 3. We can either roll a 3 or a 6, so there's 2 of those we can do. Now, is there any overlap there? Why, yes, 6 is going to appear twice, so we have to subtract 1 from that. So this is not mutually exclusive. We have to subtract that 6 that appears twice, and that's going to give us 4 over 6, or 2/3 again. Right, and that's all we have for this. So remember, if you're dealing with the probability of one or the other, you have to make sure they're not overlapping, or you have to remove it. And then for independent, all the way back up here, all you have to do when you're doing A and B, or A then B, is multiply those together. When it's dependent, you have to see how it affects that. All right, now let's give you some practice problems to do. First one, you're going to have 4 reds. You're going to have 2 blues and 3 greens. And I want the probability of pulling a red, then a green with replacement, the probability of a red, then a green without replacement. Let's do the probability of a blue, then a blue with replacement. Let's do that without replacement. All right, then let's say you have a 6-sided die, so a normal die. What's the probability of rolling, or let's say you're looking at rolling a 6 or a multiple of 3. Now that's stupid. Let's say you're rolling a prime or an even. Is this mutually exclusive? And then tell me what the probability is. And then finally, I want you to tell me what the probability is going to be for flipping a heads, then rolling a 3, then after that rolling an odd. All right, so go ahead and do those practice problems, then we will get going with these. Make sure you're pausing. All right, let's get started. The probability of pulling a red then a green will be, reds we have 4 out of, how many do we have total? 7, 9, so 4 out of 9 times green is 3 out of 9, so this is going to be 12 out of 81. For red then green without replacement, we have a 4 out of 9 chance the first time, then we're down 1, so this becomes 3 out of 8. And so that's going to be 12 over 72, or whatever that reduces down to. For blue then blue, that's going to be a 2 out of 9 chance, and then a 2 out of 9 chance, so this is going to be 4 out of 81. Then for blue then blue without replacement, we have a 2 out of 9 chance, and then we lost 1, so it's a 1 out of 8 chance. So we have a 2 out of 72 chance, and you're going to want to reduce that. All right, for a 6-sided die, we're looking at primes or evens. What are prime numbers? Well, it's 2, 3, and 5. And evens, 2, 4, and 6. So are these mutually exclusive? No. Right? We're dealing with the 2 there. So what's the probability of it being prime or even? Well, we have 3 different primes we can use. We have 3 different evens, but we have one of those that overlaps, meaning that our options are 5 out of 6. We have 5 of the 6 of those is going to be a prime or an even. All right, and then for this last one, looking at the probability of heads, then a 3, then odds. Are these dependent or independent? They're independent. The fact that we flipped a heads or a tail won't affect the 3. The fact that we rolled a 3 won't affect the odd the next time. So this is going to be the probability of heads times the probability of a 3 times the probability of an odd. So this is going to be 1/2 times, there's only 1 3 in the 6s, and 3 of your dice, heads, whatever they're called, are odd. So this is going to become 3 out of 36 times 2, or 72. And then you'd reduce that. Right, that's the last lesson. Go ahead and do the homework.